Alternating current, also known as AC current, describes the alternating flow of electric charge that periodically changes in direction and magnitude. Unlike DC current, the voltage of an AC current source will go from positive to negative, usually following the shape of a sine wave, with some exceptions such as sawtooth waves and square waves used in music generation and timing circuits. The AC sine wave has all the usual properties of a sine wave, which all have different resulting effect on supplied current. These include amplitude, DC offset, peak-to-peak, frequency, period, phase, and RMS. Amplitude describes the positive or negative peak voltage from the zero value of the wave. DC offset describes a vertical translation of the average zero voltage value due to a DC source or load being introduced at some point in the circuit. This is often an undesired effect as it can cause faults when passing through AC-specific components such as transformers or cause distortion in analog equipment such as amplifiers and speakers. Peak-to-peak describes the difference between global maxima and minima of the wave, which will always be twice the amplitude if there is no DC offset. Frequency describes how many periods, repetitions, occur within 1 second, given in the SI unit of Hertz. Period inversely describes how much time it takes for a single repetition of the wave, usually given in milliseconds for an AC circuit. Phase describes the horizontal translation of the wave, given as an angle in degrees or radians. RMS stands for root mean square voltage and is also known as effective voltage. It is a very useful metric for describing an AC sine wave as it considers the difference between instantaneous voltage, the equivalent DC voltage that would be delivered over time. For example, the typical 240 volt single phase power that is delivered at Australian household outlets has a peak amplitude of 340 volts. However, as the waveform is only momentarily at that peak value, the effective voltage that any load would experience is only 240 volts. RMS value is also the value that a multimeter would read and is what is used for any power calculations. AC current is most commonly used in countrywide power distribution where it can be run at much higher voltages, resulting in less power lost due to resistance and the heat from the same power load, increasing its efficiency. Due to the availability and simplicity of transformers in comparison to DC-DC converters in the early days of the power grid, this high voltage could then easily be stepped down to different levels for businesses and households. Power distribution with AC current gets more complicated again as multiple phases are introduced and ran on different lines. The advantage of this multi-phase power, often 3 phases, is that by connecting multiple phases of power to a load, the effective voltage is no longer from peak to neutral, but instead from phase to phase. With 3-phase power in Australia providing 400 volts, however in practice it is much closer to 415. This can allow high-power appliances such as aircon and workshop equipment to run at higher power or in a more efficient manner. Multi-phase power is also incredibly important for synchronous motors and generators where the different poles all run on different phases.